Hey there, it's your old pal Mr. Cook. We're going to work on the Unit 2 Part 1 group work. This is the same one that we went over in class. So let's get working on it. First couple problems I'll deal with factoring, so we only need to get it into factored form. We don't need to solve. So we just use the rules that we're used to using. The first one that we have here is just a difference of squares problem. I know it's difference of squares because I've got even exponents all the way around and then subtraction in between them, and there's only two terms. It's really easy to do difference of squares, and even easier if you can factor out a greatest common factor like what we can do here. So 9 and 144 are both divisible by 4, so I factor that part out first. So 9 times parentheses. Then we have x squared, and 144 divided by 9 is going to give me 16, so I get minus 16 y to the fourth. Now this is a difference of squares problem, so I have a square, a minus, and another square, so I square root both of these, and I factor it. So square root of x squared is x. Square root of 16y to the fourth is, well, square root of 16 is 4, so 4. Y to the fourth, the square root of that is going to be y squared. So I would just make these into conjugates, so I have a negative 1, and then I also have x plus 4y squared, and now my expression is completely factored. I have to watch out for this part of it, because if this is like an x squared, I could still do more factoring, because that would be another difference of squares problem. But, you know, in this problem, we don't have to worry about it too much. And, you know, keep in mind that the group work and the reviews, these are more difficult than the tests. So really what we're supposed to get from here is that, you know, we need to make sure that we understand how to factor difference of squares problems. They can be as easy as just, you know, x squared minus 25 or something like that, you know, and then in this case you just take the square root of this, square root of this, and then you just make the conjugates, so like x minus 5, x plus 5. So if you can do something as simple as that, then, you know, you're going to do fine for that part. For this one, we're just you know, factoring again. So we look to factor out the greatest common factor. So greatest common factor is another thing that we look to factor out. We already did that actually earlier with this 9. We factored it out because 9 was divisible into both of these terms. We just look for that particular thing. What divides into all of the terms? Well, if we have 15x squared y to the third, so I know that that's it's got a y in it and an x. This one is negative 3y to the fourth. That has a y in it as well. No x values though. And then I have 45y. So I know that 1y will be able to divide out of all of these, so I'll take that outside of the parentheses. And then also I notice that 15, 3, and 45 are all divisible by 3, so I can divide 3 out as well. If I divide 15 by 3, I get 5, so 5. I don't divide any x's out, so that's going to stay as x squared. And then y to the third, if I divide out a y, I get y squared. Negative 3, if I divide out a 3, I get a negative 1. And then if I have y to the fourth and I divide out a y, then I get y to the third power. And then 45 divided by 3 is 15. And y divided by y just leaves me with 1. So now this is completely factored and I'm all done. But remember, greatest common factor can look like a bunch of different stuff, even if it was something like, you know, 18x to the third power plus 9 x or something. You know, I could divide out, so I know that 18 and 9 are both divisible by 9, so I'd factor out a 9. And then I know that x to the third and x both have an x in common, so I'd factor out an x. So 18 divided by 9 is 2. X to the third divided by x is x squared. And then 9x divided by 9x is just simply 1. So, you know, that's how a greatest common factor problem might also look. For the third one, this is our bread and butter. This is just regular old factoring. So we do the first coefficient and then multiply that times the constant. So we need to find numbers that multiply together to be negative 30 and add together to be negative 1. So you know that I have factoring videos earlier, so if you still struggle with factoring, take a look at those. That'll help you out a little bit. So numbers that multiply together to be negative 30 and add together to be negative 1, that's going to be negative 6 and positive 5. So we just go ahead and, you know, use our lead coefficient of 2, and then that's going to be a 2x minus 6 and 2x plus 5. And then we just divide out the common factor. So 2 and 6 are both divisible by 2. 2 and 5 are both divisible by 1. So if I divide out the 2 from the 2 and the 6, I get a 1x. And then 6 divided by 3 is, 6 divided by 2 is a 3, so minus 3. And then 2x plus 5 divided by 1 just keeps it as itself, 2x plus 5. So then we're done. That's factoring for you. So just make sure you know your factoring algorithm. Even if you're using like the box method, use that. But this is all that you'd really need to do. And next we have to solve, and we're solving using any method. That's how it's going to look on the test. We just make you use any method. We're not going to be really picky about which one you use. As long as you get the job done, you're good to go. So when we're solving a quadratic, we can think to use a couple different methods, factoring being a big one, or of course the quadratic formula. You don't necessarily have to do completing the square. That's kind of like, a worst case scenario. So typically go with either factoring or quadratic formula, whichever one you're more comfortable with. I'm really comfortable with factoring, so I always look to do that first, and then I go to the quadratic formula if that doesn't work. And, that really helps out, especially for something like number 4, because this does factor. Numbers that multiply together to be negative 12 and add together to be positive 4, that's positive 6 and negative 2. So I take the lead coefficient 3x plus 6. That's one of my factors. And then 3x minus 2. I divide out the common factor from both of them. 3 and 6 are both divisible by 3. 3 and 2 are both divisible by 1. So this turns into x plus 2 for one of my factors. Then the other one is going to stay the same, 3x minus 2. So I set both of those equal to 0, as I usually do with solving. Just a quick aside from that, if this is anything other than 0, like if it's a 10 or a 12 or a 15 or whatever, you need to turn it into 0. So you need to subtract that number over to the other side to make sure that one side is equal to 0. That has to happen before you either do your factoring or quadratic formula. Anyways, so now that this is factored, I set each factor equal to 0. X plus 2 equals 0. I subtract 2 from both sides. I get x equals negative 2. That's one of my answers. I can take negative 2 and plug it back in for x, and I should get 0 if I want to check my work. And then the other one, 3x minus 2 equals 0. Solving that, I add 2 to both sides. So 3x is equal to 2. Divide by 3, I get x equals 2/3. So that's another solution that I have for x, and I could plug 2/3 in for x, and I should expect to get 0 for the answer for that one. For number 5, this one won't factor because I can't find any numbers that multiply together to be 10 and add together to be 1. Well, any integer values that do that. So I'm just going to go straight into quadratic formula. So I label my a value 1, my b value 1, and my c value 10, because that's from the standard form, ax squared from plus bx plus c equals 0. And remember that it has to be equal to 0 for it to be in standard form for solving. So those are my a values from there, my b value and my c value. Now I plug it into the formula. The quadratic formula is negative of b, so that's 1, plus or minus the square root of b squared minus 4 times a times c. And then we have over 2 times a, which is 1. So evaluating some of this, I get negative 1 there, plus or minus the square root of something over 2. Let's see what that something is. So 1 squared is 1. 4 times 1 times 10 is 40. 1 minus 40 is negative 39. Oh, we got a negative on our radical. So we know what we need to do with that. We move it to the front of the radical symbol, and we get negative 1 plus or minus I times the square root of 39 over 2. And then from there you need to reduce the radical if you can, but 39 is actually only divisible by 3 and 13, so it doesn't reduce any further than that. So those are your two x values, negative 1 plus the square root, I square root of 39 over 2, and negative 1 minus I square root of 39 over 2. Okay, those are that's solving. Next, we're going to do solving by completing the square. So once again, we're not going to make you use any method, but here's how we would solve it by completing the square. We're just going to go through the step-by-step process that we went over in the notes. So I'm just going to follow those kind of to a T. What we do first is get rid of the constant value on the left-hand side. So we subtract 5 from both sides. We get 2x squared minus 12x is equal to 2. Now, since we're solving, the next step that we do is divide everything by the lead coefficient. So the lead coefficient is 2 in this case, so we divide everything by 2 on this side and on this side, and we get x squared minus 6x is equal to 2 over 2, which is 1. If I was converting this from standard form into vertex form, like if it was a graphing expression, I wouldn't do this step. I would just factor out the 2. But since we're solving, we just divide everything by 2. Next, we turn this into a perfect square. So what we do is we take the b value, which is attached to x, so negative 6, and we divide it by 2. Every single time you take the b value and you divide it by 2, no matter what, it's always dividing by 2. Negative 6 divided by 2 is negative 3, so that gives us our perfect square, x minus 3 squared equals 1. But the thing is that x minus 3 squared is not the same as x squared minus 6x. It's actually a little bit different. I'll show you that in a second. But to get to this perfect square, what we needed to do was add on a number, a constant value, to this to turn it into a perfect square. And that constant number is found by adding this negative 3 that we just got and squaring it. So we're going to keep this equal, do that on this side as well. So we need to add on negative 3 squared. So whatever this number is, you square it and you add it onto this side as well. If there was a lead coefficient, which there isn't, you'd also multiply that in the front. But we don't have to worry about that for right now. Negative 3 squared is 9, so we get 1 plus 9 is equal to x minus 3 squared. So I'm just adding the 1 and the 9, and I get x minus 3 squared is equal to 10. Now we just use order of operations to get x by itself, so we take the square root of both sides and we get x minus 3 is equal to the square root of 10. And watch out, because whenever you take the square root of a squared variable, remember that you always have to put a plus or minus in front there, because we technically will have two solutions that we can get from that x value, potentially. Next, to get x by itself, we add 3 to both sides and we get x is equal to positive 3 plus or minus the square root of 10. And that's going to be our answers for x by completing the square. If you wanted to, you could go back and do this problem over again and use a different method like quadratic formula just to practice a little bit, because you already know what your x value is supposed to be, 3 square root of 10, 3 plus or minus square root of 10, and you know that you can practice your simplifying radicals and stuff, because that's what the answer is supposed to be. All right, moving on. So now we're dealing with complex numbers and the just doing the different operations. So that's when we use our calculator for the most part. So on problem number 7, we're multiplying, so just make sure you put parentheses around the complex number 5 minus 2i and enter. Oops, wait, no, I was supposed to multiply, so parentheses 5 minus 2, and then I is when we hit second and the decimal value. That gets us an I right there. And then the next one is going to be 7 plus I, so second I, there we go. And then parentheses, and then just hit enter. They're multiplying, and you get your answer, 37 minus 9i. Easy enough. Number 8, we're just subtracting, so we're going to do the same thing. Just enter it into our calculator, 4 minus 7i, and then minus parentheses 2 plus 6i. Enter, and we get our answer for that one, 2 minus 13i. If you did this by hand, just remember to distribute your negative in there, and then it's just combining like terms. If you're doing this one by hand, just remember that it's the same as foiling, and that when you get that I squared is equal to negative 1. That's a really important thing to remember for complex operations, especially for something like number 9. So number 9 you can't do on your calculator just straight up. So if you try to do it, square root of negative 5, and then times the square root of negative 7. It'll give you an error message, and the reason that that's the case is because it can't handle the negatives under the radical. So the way that you can get around that with your calculator and just doing it by hand is by moving the negatives out front, just like what we did in that previous problem, number 5. Moving the negative out front, it becomes an I, so this is going to become I square root of 5 and I square root of 7. And then it's just actually easier to do it by hand than even type it in your calculator, because you get I times I, which is I squared, and we know what that's going to turn into in a second, negative 1. And then also square root of 5 times square root of 7 is the square root of 35. So I squared is negative 1, so it gives us our answer, which is negative square root of 35. All right. Then we have number 10. Number 10 is just simply distributing. You can do that one by hand pretty easily, probably faster than you can do your calculator. Negative 3 times 16 is negative 48. Negative 3 times 4 is negative 12. And you're done. With division, remember to show your work here. You need to show that it's when you're dividing complex numbers, you have to divide by the complex conjugate of the denominator. That's the work that you need to show when you're answering these questions. Other than that, it's okay to plug it on into your calculator and get the answer, but we need to make sure that you know that you're multiplying by that complex conjugate. Number 12, same thing, multiply by the complex conjugate. In this case, it would be 9 plus 7i. The complex conjugate is just simply the opposite sign of whatever you're doing. So if you're subtracting, you add. If you're adding, then you subtract, same thing. So when we type this into our calculator to divide to get our answer, here's what we do. We have to make sure that the numerator and denominator are in parentheses. So parentheses 6 minus 3i divided by parentheses 7 minus 2i. All right, and then you hit enter, and you get some lousy decimal value, but you know you can turn that back into a fraction by hitting math, and then enter, enter. So it turns it into a nice reduced fraction. So we have a 48, and then a negative 9i, and that's all over the common denominator, which is 53. So here is your answer. If we do that same thing over here, let's type those in real quick. Let me move that down so you can see the screen. So we have parentheses 6i plus 5 divided by parentheses 9 minus 7i. And then enter, and you get another decimal value. So math, enter, enter, and we get 3 plus 89i over 130. And there's our answer for that one. So that completes the first page of the group work. Just make sure to ask questions if you have any. Ask your teachers. Come in before school or after school. Get some help. All right, that's it.